what are like terms and how can we identify them? That's what we're going to talk about in this video. We're not going to simplify or anything yet. We're just going to talk strictly about how do we identify like terms. And what are like terms? Well, they are terms that have the same variables raised to the same exponents, or they are constant terms. Constant terms would just be numbers with no variable. They are like terms as well. So we have three examples with varying different terms that we can identify as either like or unlike. So number one, we have x plus 10 minus 3 halves x. Okay, so notice here we have an x. Here we also have an x raised to just the exponent of a 1, right? If we have an exponent of a 1, it's not there. So we could consider these what are called linear terms. You'll hear more about that in algebra and algebra 2. But those would be like terms. So we would have x, and we would also have negative 3 halves x. Those would be like terms. And then the only other term we have in there is a 10. So 10 would be another term. It just doesn't have any like terms in this specific expression. It is the only constant term. Okay? So these two we said were linear terms, and this one was our constant term. And once again, you might not be throwing out those vocabulary words in pre-algebra class, but as you move forward in algebra 1 and algebra 2, you will be using those terms, so might as well show them to you now. Number 2, 3y squared plus 7y minus y squared minus 12. Okay, notice we have a y squared and a y squared, so we could write those down, 3y squared and negative y squared, and we'll talk about what kind of terms those are in just a second. Then we have a 7y. Do we have any other y terms? No. And then we have a negative 12. Okay, so we already know that the y would be a linear term, and the 12 would be our constant term because it's just a number. Linear term means the exponent on the variable is just 1. Now, when we have an exponent of a 2, we actually call these quadratic terms. Okay, so those are quadratic terms. And like we said, we don't have to know the name for those right now, but knowledge is power, right? Okay, number 3, 10 plus 4s minus 8 plus s plus 6q. All right, well, here we have a 10, and here we have a negative 8, right? So let's write these down here. 10 and negative 8, those would be our constant terms. Now here we have a 4s and we have an s. So 4s and s, those would be like terms. They're also linear terms. And then here we have a 6q. Okay, so now 6q would also be considered a linear term because the exponent on q is a 1, but it's a different variable, right? It's not s. So 4s, s, and 6q would not be like terms because they don't have the same variable. Okay, so that's how we can identify like terms.